Hello viewers, in this tutorial we will try to know the basics of time series analysis, and the next part of this video we will try to analyze it using R. So what is time series analysis? One of the most crucial data types for empirical research in time series data. To examine how a certain asset, security or economic variable evolves over time, time series analysis can be helpful. Time series refers to a collection or succession of data points that are indexed by time. A time series is most frequently defined as a sequence taken at successive, evenly spaced moments in time. A time series is a collection of observations. If we let yt is a time series, then t is equal to 1 up to n is a series of time. So it is a function of time. Let us consider yt is a function of time, f of t. Then this is a time series process. So what is time series analysis? Time series analysis refers to techniques for examining time series data in order to draw out relevant statistics and other aspects of data. It takes into account the possibility that the data points collected over time may have an inherent structure such as autocorrelation, trend, or seasonal variation. Time series analysis, which is particular to time-based problem statements, provides a foundation for prediction and forecasting analysis. Analyzing the historical dataset and its trend, understanding and comparing the current condition with prior stage patterns, and understanding the factor or factor influencing certain variables in different periods. So assumptions of time series. There are different assumptions of time series, but the three are important. The interval between the data point must be equal. There must have an interval equal-space distance between two time points. It must consist of homogeneous set of variables. It must comes from a homogeneous set of variables and homogeneous set of values. Data must be available for long period. Applications of time series analysis. There are several applications of time series, but these are extensively used, such as economic forecasting, sales forecasting, budgetary analysis, stock market analysis, yield projection, process and quality control, inventory analysis, workload projections, utility studies, census analysis, and infectious disease forecasting. Now the component of time series. There are four types of components in time series analysis. So they are trend or secular trend or long-term movement, cyclical variation, seasonal variation, random or irregular variation. What is trend or secular trend or long-term trend? Secular trend. It is general tendency of the time series data to increase or decrease during a long period of time is called trend. In this picture, you can see that the red color line is called the trend. The above picture shows this is the upward trend, while the below picture shows this is a downward trend. The concept of trend does not include short range of oscillations. There are several types of trends. It can be linear or straight line, or another can be non-linear. Cyclical variation. The second component of a time series is cyclical variation. It is the rise and fall of a time series over periods longer than 1 year. A complete period is called a cycle. A typical business cycle consists of a period of prosperity followed by periods of recession, depression, and then recovery. Almost all the economic and commercial series, for example, series relating to prices, production, and wages, are affected by business cycle. In this picture, this is an example of batteries sold by national battery retailers. Here, the x-axis shows the time year from 1991 to 2010, and the y-axis, the vertical axis, shows the batteries sold. So you can see that in 1991 the quantity of battery sold is increasing, but in 1994 it's decreasing. So this is the prosperity here. 1991 to 1903 this is the prosperity, but 1994 this is depression, and the red line indicate the secular term or long term trend. Okay, now the third component of a time series is the seasonal variation. Patterns of change in a time series within a year. These patterns tend to repeat themselves each year. Many sales, production, and other series fluctuate with the season. The unit of time reported is there either quarterly or monthly. Most of the economic time series are influenced by seasonal variations, like price, production, and consumption of commodities, sales and profits in a departmental store, etc. Here, the figures is an example of seasonal variation using sales of baseball and softball equipment, Harsar Sporting Goods, 2008 to 2010 by quarter. So, there is a distinct seasonal pattern to its business. Most of its sales are in first and second quarter of the year, when schools and organizations are purchasing equipment for the upcoming seasons. During the early summer, it keeps busy by selling replacement equipment. It does some business during the holidays in fourth quarter. Irregular variation or random variation. Many analysts prefer to subdivide the irregular variation into episodic or residual variation. Episodic fluctuations are unpredictable, but they can be identified. The initial impact on the economy of a major strike or a war can be identified, but a strike or war cannot be predicted. After the episodic fluctuation have been removed, the remaining variation is called the residual variation. The residual fluctuation, often called chance fluctuation, are unpredictable and they cannot be identified. Of course, neither episodic nor residual variation can be projected into the future. Now, several time series process. There are several time series processes like stochastic process, stationary process, non-stationary process, weakly stationary process, strictly weak stationary process. So what is stochastic process? It is a random process that is a collection of random variables ordered in time series. If y is a variable in t time, then its collection when t is equal to 0, 1, 2 up to n, the ordered collection of its is called stochastic process. Now, what is stationary process? If yt is a time series, then if its mean and variance is constant over time, it means if its mean and variance does not change over time, then it is called stationary process. On contrast, non-stationary time series or non-stationary process is that if the mean and variance of the time series is not constant over time, that means the mean and variance changes over time, that is non-stationary time series. So then what is weakly stationary process? The weakly stationary process is a stationary process for which mean function and covariance function is independent of time. It means it's also changeable. It is a non-stationary time. It is like non-stationary time series. So this figure below differentiate the stationary and non-stationary time series. Here, the non-stationary time series fluctuate greatly and have mean and variance changes over time. But in stationary time series, the mean and variance are not changing over time. Test of stationarity, that is augmented Dickey Fuller test. The augmented Dickey Fuller test it is a unit root test for stationarity. Stationarity is a discardable property of a time series. We need stationary data to predict easily the time series data. If a time series data is stationary, then it is more easier to predict, to forecast the data. But if the data is non-stationary often show some difficulties, so great difficulties in predicting the data set. So if the data set is non-stationary, then it is our duty to make it stationary first. So how do we check our dataset is non-stationary or stationary? There is a well-known test, that is Augmented Dickey Fuller test. The p-value is less than 0.05, then we can reject the null hypothesis, or if the p-value greater than the 0.05, then we cannot reject the analysis or null hypothesis is accepted. Then what can we do? We have to take difference operator. It is a more suitable approach. The augmented Dickey Fuller test can easily handle more complex models than the Dickey Fuller test, and it is a more powerful test. Now the difference operator for handling stationary data. Stationary is a discardable properties of time series analysis, because if our dataset is non-stationary, then we cannot predict the data. So before making a RIMA model or before making forecasting, we need to make our data stationary, because non-stationary data, in non-stationary data, the mean and variance changes over time. So what can we do? We need to take difference so that the mean and variance can be stabilized. So differencing can help stabilize the mean and variance of the time series. It is a method of transforming a non-stationary time series into a stationary. It can also called a pre-processing step, data pre-processing step for a RIMA model. The first difference of a time series removes a linear trend. It means difference 1. The second difference can remove the quadratic trend of a time series data. So we assume that yt a time series data, then the first difference can be written as wt is equal to yt minus 1, but the symbol wt which represents the first difference is not always true. Sometimes it is used to denote the first difference operator. So we will write del yt is equal to yt minus 1. Here the del is called the differencing operator. This is called first difference. Now the second difference, we can write del square yt is equal to del yt minus 1. So this is the process we can take second differences. So differencing is important for making non-stationary time series into a stationary time series for ease of prediction. Autocorrelation function. One simplest test of stationarity is based on the so-called autocorrelation function ACF. The ACF at lag k, denoted by rho k, is defined as rho k is equal to gamma k by gamma 0 is equal to covariance at lag k divided by variance. What is lag? Lag is nothing but the difference between time series observations. So if k is equal to 0, it means lag equals to 0, then the value of the autocorrelation function will be 1. It means the highest value. The value of the autocorrelation function ranges between -1 to +1 as the correlation coefficient exists. So the autocorrelation function defines how the data points in time series are related on average to the preceding data points. The autocorrelation function ACF is used to determine the order of moving average model, MAQ model, for building a RIMA model. Then partial autocorrelation function. The partial autocorrelation function is another effective method to determine the serial dependencies. It is more similar to autocorrelation. It measures correlation between time series observations that are k time periods apart after controlling the correlation at intermediate lags. You can see the formula here. Here xt minus 2, xt minus 1, this is a time series, but the partial autocorrelation function calculates the correlation. There is a covariance between xt and x2 minus 1 after controlling the intermediate lag xt minus 1. The partial autocorrelation function is used to determine the autoregressive order P. This is the basics of time series analysis.